Let us prove the following identities. Okay, so we'll start with part A, B, C up to H. Okay, so part A, prove that tan squared x plus 1 is equal to sec squared. Okay, so solutions. So part A, we have tan squared x plus 1 equal to sec squared x. Okay, so to prove that, we are going to pick a side. You can either start from the right or the left hand side. Okay, so here it's easier to start with the left hand side, so start with the left hand side and prove that it's equal to the right hand side. So we have tan squared x plus 1. Okay, so tan squared x plus 1 is the same as tan x this all squared plus 1. Okay, then from here, tan is equal to sine x divided by cos x, so we have sine x divided by cos x all this squared plus 1. Okay, then from here we have this is the same as writing sine squared x divided by cos squared x plus 1. Then we can put this, we can express this into a single fraction, and this will give us the common denominator is cos squared x, so it will be sine squared x plus cos squared x. So sine squared x plus cos squared x is equal to 1, so it will be 1 over cos squared x, and this is the same as writing cos x all this squared. So 1 over cos x, it's sec squared x, which is equal to our right hand side. Hence proven. Okay, part B, we have sec x minus cos x equal to sine x tan x. Okay, so even this one you can do the same. You can either start with the right hand side or the left hand side. Okay, so using the left hand side, we have sec x minus cos x. So we can convert sec x into cos or sine. So it's sec x is just the same as 1 over cos x minus cos x here. Then we can express this into a single fraction. So our common denominator is cos x. So that will be 1 minus cos squared x. So 1 minus cos squared x here, from the identity, or just say since sine squared x plus cos squared x is equal to 1, then if we make cos x the subject, or if we make sine squared x the subject, we have is equal to 1 minus cos squared x. So where there is cos squared x, we are putting that. So we have sine squared x divided by cos x, and we can write this as sine x multiplied by sine x over cos x. So we can see that this is tan, so we have sine x multiplied by tan x, which is equal to our right hand side. Okay. Part C. So we have sine theta plus cos theta in the bracket squared is equal to 1 plus sine 2 theta. Okay. So using the left hand side, we have sine theta plus cos theta squared. So we can expand this. So when you expand, we are getting sine squared theta plus twice sine theta cos theta plus cos squared theta. So this is the same as sine squared theta plus cos squared theta plus 2 sine theta cos theta. Okay, so you can easily see that sine squared theta plus cos squared theta is 1, so we put 1 here, then 2 sine theta plus cos theta. Okay, so 2 sine theta cos theta is the same as sine theta cos theta plus sine theta cos theta, which is the formula for the double angle identity. So we have sine 2 theta, which is equal to the right hand side, hence proven. Okay, so part E. Part E, let's start with the right hand side. So we have tan squared x over 2, which is the same as sine. So tan is equal to sine over cos, so it will be tan squared x over 2 divided by cos squared x over 2, and these are the half angle identity equal to, so these are the half angle identities, so we can substitute here. We have 1 minus cos x squared, now because of this square, divided by 1 plus cos x squared okay, then since it's a squared, so it means this squared, so we are getting 1 minus cos x divided by 2, all this divided by 1 plus cos x over 2. Okay, so if we multiply by 2 both the numerator and the denominator, we have 1 minus cos x, 1 plus cos x, which is equal to the left hand side, hence proving. So here I've just substituted the half angle identities. Okay, part F, we have sine 2x plus sine x divided by 1 plus cos 2x plus cos x equal to tan x. So let's start with the left hand side. So we have sine 2x plus sine x divided by 1 plus cos 2x plus cos x. Okay, so here this is the double angle identity. Here if we apply sine 2x is equal to sine 2x is equal to what? So sine 2x is just equal to 2 sine x cos x plus sine x, then divided by 1 plus cos 2x is equal to cos squared x minus sine squared of x plus cos x. So from here we can just convert sine x here. we can convert sine x so that in the denominator we just have cos as the only trigonometric function here, trig ratio here. So sine x cos x plus sine x divided by 1 plus cos squared x minus, so here to be 1 minus cos squared x plus cos x. Okay, then we have 2 sine x cos x plus sine x, all this divided by 1 plus cos squared x minus 1 plus cos squared x plus cos x. Okay, so from here now we can add this plus this, then 1 minus 1, so we have 2 sine x cos x plus sine x divided by so this will cancel that, then this is 2 cos squared x plus cos x. So in the numerator we can factor out sine is common, so we can factor out sine x, so we have 2 cos x plus 1. In the denominator we can factor out cos x, so cos x remaining with 2 cos x plus 1, and this is equal to, so we can cancel that, then we have sine x divided by cos x, and this is equal to tan x, which is our right hand side, hence proven. So you can try to attempt to solve the rest of the identities there. Okay, yeah, so you can submit to the same WhatsApp number for confirmation, 0973 40 37 93, 0973 40 37 93. Okay, thank you so much. Thank you for following.